All right, hello everybody. So today we are going to learn about a trend. Trend means a pattern, and the pattern we're going to learn is called atomic radius. So again, all we're learning is just a specific pattern or trend on the periodic table, okay? So before we learn that, we just have to review a couple of words that sound simple, but we end up getting mixed up on them. So when we say something increases, that means it gets bigger. So if something is going to get bigger, what happens is it starts small and then it goes bigger. Okay. If something decreases, it's the opposite. It's going to get smaller. So that means you start with the big thing and end up smaller. Okay, so just keep those words in mind. That's going to help us define these trends or patterns. So our first pattern we're going to talk about is atomic radius. So here's what that means. Radius should be a familiar word, so hopefully this isn't super scary. It's the distance from the nucleus to the edge of the electron cloud. So the atom is basically a circle. You've all seen circles in geometry class. So the center of the circle is our nucleus, where we have protons living, okay? So radius in a circle means from the center just to the edge. So in an atom, it's from the center of the nucleus out to the edge where the electrons are. So it's just to the edge of that electron cloud. So make sure you draw this on your diagram so you remember what an atomic radius looks like. It looks just like the radius of a circle that you learned in geometry. So you got it. Okay, so here is the trend, here is the pattern on the periodic table. As long as you can remember what a snowman looks like, you can do this pattern. So I'll even sing you the song. Do you want to build a snowman? If you can do that, you can do this pattern. Look at a snowman over here when he is standing up. On the top, his head is very, very small and his butt is very, very, very big. The same thing happens as I look from the top to the bottom of a group. The top of the group is like the snowman's head, and so we have very, very small atoms. As we go down, our snowman gets bigger, bigger, bigger. So at the bottom of the group, we have very large atoms. So it looks like a snowman. But then the snowman goes outside and it's winter and it's very slippery and he falls over. When the snowman falls over and we look at atoms in a period across, his butt has stayed over here on the left-hand side. So that's where the bigger atoms are. And his head landed way over here to the right. And so the small atoms are on the right. So if you can remember, my snowman stands up, small on the top, big on the bottom. Then he slips and falls down. His big butt is on the left and his tiny head is on the right. That will tell you all the sizes of the atoms. So let's look at this one with a little bit more detail. In a group, we said that's our snowman who is standing up. So he's like this. So as we go down a group, atomic radius increases. So that means it's little at the top and big at the bottom. So we're going to compare these two elements. We have lithium and we have potassium. Both of them live in group 1. And we've got that right over here. We've got lithium and potassium, but they are in different periods. So lithium is up here closer to the top of the periodic table. That is in period 2. The period, remember, tells us the number of energy levels. So something in period 2 has 2 energy levels. Those 2 energy levels are right here in our diagram, okay? Now, if I compare that to potassium, potassium is down a little bit farther in period 4. Because it's in period 4, the period tells us the number of energy levels. So potassium has 4 energy levels. So I see those 4 circles, those 4 energy levels here in potassium. Okay, so if I compare lithium and potassium, lithium with its 2 energy levels is a smaller size atom. It has a smaller atomic radius. Potassium is much bigger with all of its more energy levels, so this one has a larger atomic radius. So the reason why this trend increases down a group is because there are more energy levels making larger atoms. So as you go down, you get more energy levels, you get bigger atoms. Now, let's look at it in a period. This one's trickier, sorry. Okay, so remember in a period we said the snowman slips on the ice and he falls down. So we have really, really big atoms on the left where his butt is, and then teeny tiny atoms on the right. So as I go across the period this way, my atoms are getting smaller. So we say atomic radius decreases as we go left to right across. Okay, so now we're going to compare two elements in the same period. We're going to compare lithium and we're going to compare fluorine. If I peek over here, here is a snapshot of period 2. So I've got lithium here and I've got fluorine here. So they live together in period 2, but they've got differences in their atomic radius. So we've got to figure out what's going on. Okay, so both lithium and fluorine are in period 2. Lithium is right here in group 1, and then fluorine was way over there in group 17. Okay, so same period, different group. Now, here the difference is all about the protons. So remember, protons equals the atomic number. So if I look at lithium, it has an atomic number of 3. There are 3 protons in its nucleus. So there are 3 protons pulling the electrons close to it. Remember, positive protons pull on the negative electrons because opposites attract. Now the same thing is happening in fluorine, but here, if I look at the atomic number of fluorine, the atomic number of fluorine is 9. So now fluorine has 9 protons. Lithium only had 3. So we still have the positive protons attracting the negative electrons. But there's a lot more protons pulling in fluorine. If I have more protons, it's like having more people in tug of war. They're going to have a stronger pull. What that ends up being is fluorine pulls more on the electrons, and that makes it actually a smaller atom. It has more people on its tug of war side. Lithium only has 3 protons trying to pull the electrons, and that's not very much to pull. So that makes the atom larger. Okay, so if I'm going to sum all of that up, why does this pattern happen in the atomic radius? It's because we have more protons pulling the electrons tighter, and that makes smaller atoms as you go across the period. All right, that's it. You did it. Good job, guys.